We're going to work here on some review problems. So we've got some up here. I'll let you take a look at that for a moment. We're working on it here. I'm going to pause it. We'll come back with the answer to the first one shortly. So what we're doing on that first one is we are going to just say that these things need to be equal to each other. So the x's are the same, so we need 1.05 to equal e to the k. So to solve that, we're going to take the natural log of both sides, and recognizing that a logarithm-based Euler's number and an exponential-based Euler's number are inverses of each other. Therefore, they're just going to cancel. And so we will enter into our calculator the natural log of 1.05, and it looks like we're getting k to be 0.049. Okay. All right. A different wave of volunteers to do that next one. I'm going to pause it again. So it looks like we're reaching consensus here. And this one is actually a little more direct than the last one. So we just want e to the 0.06 to equal that base b. And it looks like when people are throwing that on the calculator, they're getting that to be 1.062. So you can see that because of this compounding that we get with Euler's number e, because remember, one of the applications of this is that if you compound 6% interest an infinite number of times, the effective annual rate is going to be this 6.2%. So because of all that compounding, you actually get a higher return than a nominal rate, than just that face value. Okay, now same idea here, but these I think sometimes throw people because when it's decay, it might be surprising or they're not quite sure what to do. I don't know. Hopefully that won't happen with this group. So if you have not been to the board yet, now is your turn to do this one. Or do we still have some that haven't yet been to the board? Yeah, nice try. So what we did is, again, we're going to equate these two. So we have the 0.94 is equal to e to the k. We're going to take the natural log of both sides. And again, that's going to just give us k. And when we plug that in, it looks like it was, what did we get? A negative 0.062, is that right? Mm-hmm. Okay. So there we have it. And the remainder of the first group, no, just one person left in the first group and 3 of the 4 in the second group can come up and do this one. And so what we're seeing here is, again, we're just going to equate these things. They have the same to the x power. And so this one is our more straightforward. We just plug that into our calculator, and it looks like we're getting I think it's 0.0923. So that's going to be the equivalent of 9.3% annual interest. So does that sound right? Ashley, okay there?
But wouldn't you be losing money?
No, it should be, you're right. 0.923, is that right?
Yeah.
And so then if we subtract that from 1, that's actually going to be, that would be what, 0.077. So it's going to be a decrease of 7.7% per year. Okay. All right. I forget where we leave off, but hopefully you know. And we'll throw Parker in with that next group right there. She's ready to get up and get after it. So we can do this problem right here up at the board. So we can distribute this because this is a plus or a minus sign. So all this junk here next to the parentheses is a multiplication. What's inside the parentheses is an addition or subtraction. Then we distribute over addition. If this was a multiplication, we wouldn't distribute, right? So if this was hypothetically, so if we changed the problem and it was n to the 11/5, and then say, I don't know how to even write this, negative 3n to the 6/5. Now, these are all three being multiplied. So it's not a distributed property. You're not going to multiply this times both of those. This is everything being multiplied. You're free to rearrange whatever order you want. The 2, the 1, the negative 3 are all ultimately going to hit each other. And you'll add all the exponents because those powers of n will all hit each other. But you're not going to take this times each of those. That would be multiplying by that twice. And that's, we don't want that. So, but we distribute because there's a plus or a minus sign. Different down here, because this is a multiplication, we can distribute. This is a power. Exponents do not distribute. Now, when you see here, these are being multiplied. So when you have a multiplication, each of these is going to get raised to that power. That's different than here, where you're not going to distribute there. You're not going to hit each of those. So you kind of get to see the difference between the different properties and when they hold, how they hold, and when they don't. Is that okay? So here we got, when these multiply, the 2 times 1 is 2. We add the exponents, negative 1/5 and plus 11/5 is 10/5. 10/5 reduces to 2. The 2 times the negative 3 is a 6. And we're going to add the exponent and get 5/5, which is just to the first. Now these are not like terms. Since they're not the same powers, we can only add and subtract like terms. So that's the end of the story. That's all we can do there. There's no more simplification that we can do. Good questions. We got to tease these out. Other questions? All right, let's tackle this one, whatever next group we have. So now these, we talked about, these are both being multiplied raised to the power, which means each of these gets raised to that power. So we're going to get the 16 to the negative 3/4, and then we're going to also get the n to the negative 12 raised to the negative 3/4. Now some people like to make this the 4th root of 16 and cube that. That's fine. I'm a believer, I can see 16 as 2 to the 4th. So I would choose, but you don't have to multiply exponents. See that the 4's are going to cancel. Call that 2 to the negative 3, which is 1 over 2 to the positive 3, which is going to eventually become a 1/8. In a similar fashion, these are going to multiply. So the negatives will cancel. 4 goes into 12 3 times. We multiply the result and get n to the 8th. So you can write your final answer either n to the 9th. 3 times 3 being 9. Thank you. So you can either write it as 1/8 n to the 9th or as n to the 9th over 8. Those are equally acceptable. Is that okay? Good to go? Okay, so we're going to try this one. Remember, this one is dangerous. You can't just start flipping things around because of this addition here. So if these were being multiplied, then you could move them into the numerator and multiply what was up there. But because of the addition, you cannot. We have the kind of traditional way of doing this, which is to make all of these into fractions, get common denominators, make it into a single fraction, multiply by the reciprocal. There's a clever way of doing this if you remember the clever way. And if you don't, that's okay. You just do it the traditional way. All right, go ahead, next group. Okay, so you can see Jeremy here has done the very clever, efficient, quick way. First, let's do the traditional way. So the traditional way is to say 2 to the negative 1 is 1 over 2. And this will be another 1 over 2, and this will be a 1 over 2 squared is 1/4. Now resist, you still can't flip these around up here because of a plus sign. So here you got to get a common denominator and add these fractions. So 1/2 is 2/4. That's our common denominator. So that's going to be 1/2. 2/4 plus 1/4 is 3/4. Now we have a fraction divided by another fraction. So we're going to take the 1/2 and multiply by the reciprocal. And now if you're not opposed to canceling, we can get to 2/3, which is the answer that we want. Now, if you've done a couple thousand of these before, which as a math teacher you have, but as a non-math teacher you may not have, there is a clever way you can multiply by the positive exponent that will cancel this largest negative exponent. And Jeremy is on to anything that will make this shorter, since he's trying to be, shall we give him the benefit of the doubt, as efficient as possible, not looking for lazy there. So when we multiply here, we'll get 2 to the first because we add exponents. We distribute here and get 2 to the first plus 2 to the 0, which is going to be just 1. And there you have your 2/3 in a very efficient way of doing it. Okay? Questions on that? Let's try another. So moving on to this one, and we're going to try to simplify that. Everything there can be written as a power. And we didn't really want to do that. So we have, this is 3 to the second to the -3, 3 to the third to the second, and that was 3 to the fifth. Word choice down here. Multiply the exponents, that's 3 to the -6, this is 3 to the +6, still 3 to the fifth. So we add exponents, that's 3 to the 0, which is 1, and then this was not a good choice. But as Ronan was doing, if you imagine these 5 3s, we can actually do this one in our head. That's a bit on the fringe. So if we gather these, we know that 3 squared, 3 times 3 is 9. There's another 9, and this 3 is still waiting. 9 times 9 we know is 81. Now 81 times 3 we can do, because 3 times 80 is 240, plus the 3 times 1 is going to be 243. So you could actually do that, but I didn't really intend for that. That was a poor choice of problems. See what we can do with this one. Okay, next group. Okay, so we are using our property of exponents. We multiply these two, they have the same base, it stays the same. We add the exponents, 2n plus n is 3n, 1 plus 2 is 3. This is still down below here as 3n plus 1. Now we're dividing two powers with the same base. The rule is subtract their exponents. Subtract the 3n, they're gone. Subtract the 1 from the 3, you just get b to the second. Okay, let's do one more real quick because I meant to give you one of these and I guess I didn't. Let's do 3 to the x squared over 9 to the x is equal to 27. And we're going to solve this for x. So we're going to solve that one. Okay, wherever we left off, come up and give it a shot. So it looks like we're kind of getting to the same place here. We're going to write everything as a power of 3. So this is 3 squared to the x. That's 3 to the third. So we're going to get power to a power, you multiply the exponents. And then when you divide two powers with the same base, you subtract their exponents. And when you have two powers equal to each other with the same base, that means their exponents are equal to each other. Now we're to a quadratic that we can hopefully do our factoring magic and get that x can be 3 or -1 both. Well done. Okay. You can go ahead and erase your boards if you want there. Are there questions on homework 27 and 28 that we need to talk about?
On homework 2849, it was page 175.
Page 175, number 29, did you say?
Yep.
Do you know what that is?
49, actually.
Was it 49?
Yeah.
Do I need to look at the book or?
Nope, I have no idea. I don't know.
You don't know what it is. Okay, so page 175. So it says here that the annual inflation rates are for a 5-year period is given by table 4.15. And you can see it's changing over that time. And this is kind of crazy. So part A says by what total percent did the prices rise between the start of 2000 and the end of 2004? So what we have is that the prices are changing each year. So we are going to start with, so our price at the end of that period is going to be whatever the original price was in 2000. Then it went up by, I think that's 3.4%. So we would multiply that by 1.034, and that would tell us the new price at the end of 2000, beginning of 2001. Then the next year it went up 2.8%. So we would multiply that by 1.28 to see how much the new price at the end of that year of 2000 goes up in the second year. And so then that would reflect then our price after those first 2 years. And then it goes up again by 1.6%. So now we'll multiply that by 1.016. And I think you see where we're headed. Then it'll be 1.023 and finally 1.027. Now if you multiply all those together, what we want to know then is what is that number? So you're going to throw that on your calculator. I'll wait a moment there. And if anybody gets it, we can get the first shot at it, and then we'll see if we get confirmation.
1.134.
1.134. 135, is that look right if we round? So okay, we round there. So that, now the question then was by what total percent did it rise over this 4-year period? So that's going to be by how, this 1.135 represents that 1 plus R. How much did it increase over that period? So the R is going to be that 0.135, which then by a percent, as a percent, is going to be an increase by 13.5%. Is that okay? And, well, I guess I answered then the question for B. It says, what's the average annual percent? Oh, no, we got to do it differently for the average. So the average annual percent for that means we're going to...
13.5
good question. I don't know that we can just do it that way. That's a fair question, but I think what we want is to say that, what I think we want is 1.135, and we would use your exact answer, not the rounded one, so you can go back. We want that to be 1 plus R to the, was it 4 years? 5 years?
2000 to 2004.
Yeah, but that was 5 years.
Yeah, so I think that's 5 years total. Is that okay? So then we want to solve for the R here. So if we just had a percent that was compounded each year, so we're going to have to write, so it's not just dividing that 1.1, that 1.3, the 13.5 by 5, but what we really want is to raise that to the 1/5 power. But don't use your rounded answer, so don't use this one. Capture that one that you got before you rounded it up here when it was, back over here. Does that make sense? Do you have that one? Anybody have that one?
1.026.
No,
No, but then you subtract the 1 and then you have to multiply.
Okay, well, okay, so we're to there, yeah. And so then, yeah, it's going to be 0.026, so it's going to be a 2.6%. Does that sound right?
That's rounded down.
Is that rounded not correctly?
Well, no, 2.5.
Oh, yeah.
2 point, what is it?
2.5582, so.
5582, so we'll say that 2.558%. Okay. Now I don't think that's the same as dividing that by the 5, so it won't be quite the same. And then in part C, it says at the beginning of 2000, a shower curtain cost $20. Make a prediction for what it would cost in 2010. So how would we do that? Anybody?
Take the average rate and then.
Yeah, so since this is not really very predictable, because it was changing every year. But if we say, well, it's gonna continue in that same average, we can use this as our percent, but again, not the rounded version. You have to go back and capture that. So we can get that one, and maybe we wanna go plus, or we can even capture it when it was still before you subtracted the one. So you can, I'm just gonna write it as 1.02558, but not using this, but using this captured version that you got before you did all that rounding. And then we're gonna raise that to the what?
10.
10. And since we said the original price of that shower curtain was at $20, so that's gonna be the cost there of that shower curtain 10 years down the road, if inflation continues at the same rate. And anybody get that?
$25.75.
Say it again.
$25.75.
25.75?
Yeah.
Anybody else getting that same thing?
Yep.
Nice. That makes sense, how we did that? Okay. Anything else? Well, I kind of blew it. I had a quiz ready for you today, but I don't think we can do it in 4 minutes. So that means since I won't see you tomorrow, I'll still try to surprise the B cohort with the quiz tomorrow, so don't tell them. Oh, wait, I need to turn this off. And so you will then see it on Monday next week after you get like 5 days to forget it all. Okay?
Oh, fantastic.
All right. So let me get you,
You need to get rid of that part of the video.
yeah, I could delete that last part.